Hello everyone, welcome to Algebra 1 with Miss Betsy. I've got a lame joke for you today, and this is such an old one, but I wonder if you can tell me what it is that you would call a train that has loaded with taffy. Well, that would be a choo-choo train. Today we're going to be dividing rational expressions. If you are using the same text that I am, we are in Chapter 12, we're in Section 3. It's entitled Dividing Rational Expressions. The text is Algebra 1 for Christian Schools. It's published by Bob Jones University Press, and I'm using the second edition, and I'm on page 489. And there's really not a whole lot of teaching to this. It's just more illustration. Dividing rational expressions, you divide those the same way you divide fractions. How do you divide a fraction? You invert the divisor and you multiply by the reciprocal. To divide, you multiply by the reciprocal. So, what we have here, let's go ahead and do our first example on page 489. This says divide x squared over 3y squared. We want to divide that by x over 9y. How do you divide rational expressions? You multiply by the reciprocal. X squared over 3y squared. We're going to multiply by the reciprocal of the divisor. And now we're going to go ahead and cancel common factors. What do we have that we can cancel? We have 3's. 9 divided by 3 is 3. We have x squared divided by x. It's going to give us a factor of x remaining in the numerator. Y divided by y squared gives us a factor of y remaining in the denominator. What do we have left? We have a factor of x, a factor of 3, and a factor of y. So what is the solution to this division problem? Well, quite simply, it is 3 times x, 3x over y. So we're not adding anything new here, we're just showing that you divide rational expressions exactly the same way you divide fractions. You divide them by multiplying by the reciprocal of the divisor. Just gets a little bit longer and more drawn out when you have polynomials that you're using that you're going to factor first. Second example is a little bit bigger. Actually, it's a lot bigger. Not harder, just lengthier, and you have to take your time to factor. So our example says simplify x plus y, quantity squared, all of that divided by 4x squared minus 4xy plus 4y squared. Now I see a mistake already, but I'm going to leave it. Divided by, and I'll show you why, divided by 9 over x squared minus xy x squared minus xy minus 2y squared. Okay, should I go ahead and factor? We've got a common factor of 4 here, common monomial factor, but no, what have I told you repeatedly? When you write a problem, and this is example 1 on page 489, example 1, page 489, you should always take the time to go back and make sure you've copied your problem correctly. Because there's nothing more frustrating than getting to the end of a problem and realizing that your procedures were correct, but your answer's wrong because you copied it wrong. And that's exactly what I did. So I'm going to verify. X plus y quantity squared. This here is supposed to be x squared, not a 4. X squared minus 4xy plus 4y squared divided by 9 over x squared minus xy minus 2y squared. Now I've verified that I didn't make another mistake. I caught it as soon as I wrote it, but I wanted to illustrate to you that take the time to make sure that you're looking for errors. I'm going to have x plus y quantity squared. I'm not going to write the extra step of just flipping so that we can multiply by the divisor and then factoring. I'm going to go ahead and factor as we go. We know we're going to have to factor this denominator. X squared minus 4xy plus 4y squared. It's a perfect square trinomial, but I'm going to write it x minus 2y times x minus 2y. Negative 2y times negative 2y plus 4y squared gives us a negative 2xy. So now we've factored our numerator and our denominator. That's just x plus y times x plus y. Times x minus 2y times x plus y all over 9. Everybody see what I did? X times x is x squared plus xy minus 2xy gives us a negative xy. Negative 2y times a positive y is minus 2y squared. So now you see that we have a factor in common that we can reduce, x minus 2y. X minus 2y. Is there anything else going on here that we can cancel? See anything? There isn't. Now, what would have happened? So we've got an x plus y squared. We have an x plus y. What would have happened if you had forgotten to invert before you multiplied? Then you would have had your x plus y in the denominator. You would have been canceling factors of x plus y. And that's that little trap that they put in there. So just because something cancels doesn't mean that you've gotten your mechanics correct, because your computation correct. Because if you had not inverted this divisor here, you would have factored this into x minus 2y, x plus y, and there would have been an x plus y in the denominator for you to cancel. You have to invert first, and then you can cancel common factors. We have 2 factors of x plus y, 3 factors of x plus y. So this becomes x plus y, quantity cubed, divided by 9 times x minus 2y. You have a lot going on. A cube right here. X plus y is used as a factor 3 times. 9 times the quantity x minus 2y. This is the simplified form of this division problem here. Once again, we're just putting together everything we've been learning to be able to come up with how to divide and simplify a rational expression. Let's go ahead and do our next example, which is still on page 489. We're going to do example number 2. Example number 2, we have, that was example 2 we just did, that's pretty lame. Next page, example 3 is on page 490. We have x squared plus 3xy plus 2y squared. All of this is divided by x squared plus xy minus 2y squared. Divided by x squared plus 4xy plus 3y squared. All of this over x squared minus y squared. Takes a mouthful just to read the problem, doesn't it? Now let's go ahead and make sure we've copied it correctly. X squared plus 3xy plus 2y squared, x squared plus xy minus 2y squared divided by x squared plus 4xy plus 3y squared, x squared minus 4y. This time I am going to show where I've simply inverted the divisor. X squared plus 3xy plus 2y squared divided by x squared plus xy minus 2y squared times x squared minus y squared divided by x squared plus 4xy plus 3y squared. Now we have to go through and factor all of these polynomials. These are both positives, so this is going to factor into x plus 2y times x plus y. Our denominator factors into x minus 2y times x plus y. Oh, that's nice. We've already got something in our first rational expression that will cancel. Times, we have a x squared minus y squared. Jumps out at you that it's the difference of two squares. X plus y, x minus y. It's dark outside while I'm working this video, and I'm hearing an owl hooting outside in my backyard somewhere. Now we're going to factor this. They're both plus again. This becomes x plus 3y times x plus y. Okay, let's go through this and see what common factors we have that we can cancel. And let me make sure that I'm going to be happy with what I see. X minus y, x minus 2y, x plus y's cancel. Okay, this is looking like I have missed something. Did I copy something wrong? Minus 2y squared. Okay, hang in there with me, class. Let me see what in the world is going on. X plus y, x plus 2y. Aha! Did you catch it when I did it? X squared plus xy minus 2y squared. I had my signs wrong when I FOIL this out. This is actually x squared minus xy minus 2xy. So this should be x plus 2y times x minus y. Now, let's see what we end up with. We have x plus 2y cancels. X plus 2y cancels. We have x minus y, x plus y. We should have x plus y over x plus 3y, which is exactly what we did. X plus 2y, x plus 2y. As long as you have the same factor in the numerator and the denominator, it cancels. X plus y, x minus y. Is there an x plus y in the denominator over here? Yes, so we can cancel that. Next factor in the numerator is x plus y. No. What about x minus y? Yes, we have a factor of x minus y in the denominator that cancels. What is our answer now? Our answer, the only factors that we have remaining, we have x plus y divided by x plus 3y. Okay? What you saw me do right there is exactly what I'm asking you kids to do at home. You work through the problem, you get to the answer. If you get the wrong answer, now when I said, okay, what did I do wrong? And I said, hang on kids, let me show you. I should have gone through and I could have gone through and said, okay, here's the answer I got. This is what the answer is supposed to be. Let me go back and see if I can figure out where my error was. And that's what I did. I went back and I found out that I had factored this denominator incorrectly. And that's what you need to do. That's why you make use of the teacher's edition that you have, or you make use of your solutions. It's not to copy the answers. It does you no good to go through and copy this answer. Or it does you no good to go through and come up with the wrong answer that I had and then just erase that and put in the right answer. You have learned absolutely nothing. But if you take the resources that you have, your study guides, your teacher's edition, and say, okay, what in the world? Oh, I see what it was. See, I'm expected to be able to go through this and catch my own mistakes. I don't expect you to be able to catch them as quickly as I do. Sometimes it might take looking at that teacher's edition to say, that, this makes sense, this makes sense. Oh, I see what I did. So use a combination of your own study skills, using me in class, using me on video, and using the resources that you have given to you. And it'll help you get through this class a lot better. So how do you divide rational expressions? Just exactly the same way that you divide fractions. You multiply by the reciprocal of the divisor, but you cancel common factors. And that would be the end of the lecture, and for some weird reason my phone is alarming.